Welcome back. In this module, we'll discuss APIs, integrations, and the modern digital supply chain. Modern digital systems rarely operate in isolation. What appears to users as a single application is often a web of interconnected services, internal systems, cloud platforms, third-party providers, data feeds, and automation tools, all exchanging information continuously. This interconnection is not accidental. It is what enables speed, scale, and innovation. It is also what reshapes cyber risk. This section explores how APIs and integrations underpin modern digital environments, why they expand organizational attack surfaces, and how cyber incidents increasingly originate not from core systems, but from the digital supply chain that surrounds them. From standalone systems to interconnected services, in earlier computing models, systems were often self contained. Applications stored their own data, processed it internally, and exposed limited external interfaces. Integration was complex, expensive, and relatively rare. Modern architectures are different. Today's systems are designed to connect. Data flows between services automatically. Applications delegate functionality to external platforms, and organizations assemble capabilities by linking components rather than building everything themselves. APIs are the mechanism that makes it possible. What APIs actually do? An application programming interface, or API, is a structured way for systems to communicate. APIs define what data can be requested, what actions can be performed, how requests must be formatted, and how systems authenticate and authorize access. From a functional perspective, APIs are enablers. They allow systems to share data, trigger workflows, and integrate seamlessly. From a security perspective, APIs are doors. Every API represents an entry point into a system. Whether that entry point is safe depends entirely on how it is designed, exposed, and governed. Why APIs expand the attack surface? APIs are often designed for automation and efficiency, not for scrutiny. They are always available, they are machine to machine, they are less visible to end users, and they are frequently exposed to the internet. Because APIs are not typically interacted with directly by people, they can receive less attention from security teams. Documentation may be incomplete, ownership may be unclear, and monitoring may be limited. Attackers notice this. API abuse has become a common technique because APIs often bypass the controls designed for human users. They do exactly what they are told at scale. Authentication without context. Many APIs rely on tokens or keys for authentication. If those credentials are exposed through code repositories, logs, misconfigurations, or third parties, attackers can interact with the API as if they were a trusted system. APIs do not question intent, they respond to valid requests. This makes credential management, scope limitation, and monitoring critical and frequently neglected. Integrations multiply trust relationships. Every integration introduces a new trust relationship. When you connect one system to another, you're implicitly trusting the security of the external system, the correctness of its behavior, the integrity of its data, and the controls around its users. This trust is often transitive. A compromise in one system can cascade into others, not because of direct attack, but because trust were extended automatically. This is how supply chain risk manifests in digital environments. The digital supply chain refers to the network of software services providers and dependencies that support an organization's operations. It includes cloud service providers, SaaS platforms, payment processors, analytics tools, identity providers, software libraries, and components. An organization's security posture is increasingly shaped by the weakest link in this chain, not just its own controls. This reality challenges traditional ideas of ownership and accountability. Why third party risk is hard to see. Third-party risk is difficult to assess because much of it exists outside organizational visibility. Organizations often lack insight into vendor security practices, rely on contractual assurances, assume compliance equals safety, and underestimate integration depth. Yet, breaches frequently propagate through trusted connections. From the attacker's perspective, attacking a smaller, less mature provider may be easier and more effective than attacking a well defended organization directly. API as supply chain conduits. APIs are often the conduit through which supply chain risk flows. A vulnerable API in a third party service can expose data across multiple organizations simultaneously. A compromised integration can become an access point into internal systems. Because integrations are designed to function continuously, malicious activity may persist undetected. Trust accelerates damage. The illusion of control through contracts. Organizations often assume that vendor contracts transfer risk. In reality, contracts transfer liability, not impact. If a third party breach exposes your data or disrupts your operations, the consequences remain yours to manage. Regulatory scrutiny, customer trust, and operational continuity do not shift with the contract. Cyber risk does not respect organizational boundaries. Why modern incidents are systemic. Many high profile cyber incidents are not isolated failures, they are systemic events. They emerge from deep interconnection, automated trust, shared dependencies, lack of visibility, and when systems are tightly coupled, failures propagates quickly. Understanding this shifts cybersecurity from a defensive mindset to a resilience mindset. Designing for interdependence. Modern cybersecurity does not attempt to eliminate interconnection. That would be unrealistic. Instead, it focuses on limiting trust scope, monitoring integration behavior, validating inputs and outputs, and preparing for downstream failure. Resilience depends on assuming that dependencies will fail and designing systems that degrade gracefully when they do. Why this matters for decision makers. APIs and integrations are often approved for business reasons like speed, efficiency, and innovation. Without understanding their security implications, organizations accumulate hidden risk. Recognizing digital supply chain exposure allows leaders to ask better questions. What happens if this provider is compromised? How much access are we granting? Can failure be contained? These questions are strategic, not technical. The key takeaway is modern organizations are ecosystems, not islands. APIs and integrations enable powerful capabilities and create powerful dependencies. Cyber risk increasingly originates not from core systems, but from the digital supply chain that connects them. Understanding this interdependence is essential for reasoning about modern cyber risk and for building systems that can withstand failure without collapsing.